So I'm going to go over 3 different examples from section 3.3. So in this section, you learned about different shortcut rules. So one is the power rule, and it's hard to recognize when you can use the power rule. So I like this example because it requires previous algebraic knowledge. So I'm going to rewrite each of these as a power function. So when you have a root, so this is the 6th root of t, that's the same as t to the 1/6 power. So this is also t to the 1/6, but still not written as a power function. If you want to bring it to the top, it would be a -1/6. So I've not done any calculus yet. I've just rewritten the problem in a way that I can now use the power rule. So when I do the derivative, you bring down the 1/6 and subtract 1 from your power. When I bring down the -1/6, this becomes positive, and -1/6 minus 1. And then just doing the addition or subtraction of the fractions, 1/6 minus 1 is 1/6 minus 6/6, so that's -5/6. And then -1/6 minus 1 would be -1/6 minus 6/6, or -7/6. So this is the derivative. This next question wants you to find all the values of x where the tangent lines to these two functions are parallel. So we need to know that parallel means they have the same slope. So in other words, we want to find x where the derivatives are equal, because derivatives are the slopes. All right, so the derivative of x to the 8 is 8x to the 7th, and the derivative of x to the 9 is 9x to the 8. I'm going to subtract the 8x to the 7 over, and I'm going to factor out an x to the 7. And so I have that x to the 7th equals 0, or x is 0. And I have that 9x minus 8 is 0, or x equals 8/9. So it says if there's more than one value, enter them in a comma-separated list. If the x value does not exist, enter any. So we have two values, the 0 and 8/9, where those two functions have the same slope. This last example is more algebraic in nature. So we have this g of x that is written in terms of another function f. And you're asked to find g prime of 3, or the derivative at 3. So we're first going to find the derivative of the derivative of g. It's a quotient, so the derivative is denominator squared, denominator, times the derivative of the numerator, I'm just going to put 2x plus 1 prime, minus the numerator, times the derivative of the denominator. I'm going to do one little simplification of this, and that's to find the derivative of the 2x plus 1. So that's just 2. Now to find the g prime of 3, I'm going to plug 3 everywhere I see an x. And now I'm going to do substitution. So I know that f of 3 is given as -2. So I have -2 times 2 minus this expression here is 7. And I know that f prime of 3 is 4. F of 3 is -2, and I'm squaring that. So I have -4 minus 28 divided by 4, or -32 over 4, or -8.